this video, we are going to learn about 18 electron rule. So there are two types of rule for finding the stability of a particular compound, that is effective atomic number rule or 18 electron rule. So what is the disadvantage of this EN rule is we have to know the entire atomic number. Consider if you want to calculate whether a Fe carbonyl group is stable or not. I have to know the atomic number of this metal. But in the case of 18 electron rule, it is not needed. We just have to know the valence electron. So mostly it is better to use 18 electron rule. So to calculate this 18 electron rule, there are two methods. Okay, oxidation state method, or we can call it as an ionic method, and another one method is neutral ligand method, or we can call it as covalent method. So both methods are very useful. It is better to know both methods, but if you are having so much confusion with finding the oxidation state and formal charge, then this method is not applicable. It will be quite tough for you. So neutral method will be easy. I'm going to explain both these methods for so many examples. With few examples, I'm going to explain both these methods. Okay. So basically, first we will see the contribution of ligands. Okay, contribution of ligands in both the neutral and this oxidation method. So consider a metal carbonyl. So just they will give like this. Okay. So how to write this? You have to write it like this: metal carbonyl. So what is this carbonyl group? So we have to write this separately and see why. Basically, they will tell that the carbonyl group has a contribution of 2. Okay, either in neutral means I'll mention as N, and oxidation method means I'll mention as OO. Okay, either in neutral or oxidation method, its contribution is 2. Why is it 2? Okay, so carbon has how many bonds? See, consider carbon has like this. Okay, basically how many electrons will be there? 4 electrons. In oxygen, so 1, 2, 3 and 4. In oxygen, 1, 2, 3, 4, 5, 6. Okay, so in order to stabilize it, what will happen is this oxygen will give away its electron here. Okay, so it will become carbon triple bond oxygen. Now, since the oxygen has 1, 2, 3, 4, 5. Oxygen had initially had how many electrons? 6 electrons. Now it only has, if you count the red dots, if you see, it only has 5 electrons now. So it is deficient. So it is plus. Okay. And then see carbon. Carbon initially it had 4 electrons. Right. Now if you count and see 1, 2, 3, 4, 5 electrons. So it has gained the electron. Okay. So it is minus. So this plus and minus will be balancing, and that's why it is a neutral ligand. So whenever there is a neutral ligand, so the neutral ligand means whether it is a neutral method or oxidation method, it is going to give the same contribution of electron. So this 2 electron is contributed to the metal. Okay, that is why it is 2. So because here 2 electrons are there, that is why its contribution is 2. Okay, then what about the hapticity of this particular compound? Hapticity means what? Basically, the metal is attached to certain group, right? So how many atoms it is directly attached? In the case of complex, we will talk about coordination number, right? So metal is attached to how many atoms directly? So if it is in case see, here the metal is attached to 4 atoms directly. So whenever the metal is attached to the atoms directly, those atoms are called as hapticity. Here it is only 1 carbon is attached, so hapticity is what? 1. Then what about the formal charge for this particular? So what is formal charge exactly means? So we will usually calculate the oxidation state, right? Consider Fe, and then Cn6 is present, and then 2 minus. So what we will do, basically, we will take Fe as X. So oxidation state of metal. So oxidation state of the metal here. Okay. And then what we will do, we will write the charge for this particular Cn minus, that is called formal charge. So in this case Cn will be -1 formal charge. Okay, so -1 means 6 times, so -6. And then this is the entire charge. Okay, entire charge is -2. So this is the general formula: oxidation state of metal plus formal charge of ligand is equal to the entire charge, overall charge. So basically we have to know this formal charge of every ligand, so that we can use this oxidation method, or even to calculate the oxidation state of the metal, we need this formal charge of ligand. For now I know for Cn it is -1. So you have to understand the concept so that it is easy to calculate. Even if you forget, you can calculate yourself. Consider in this case, I am going to calculate the formal charge of carbonyl ligand now. Okay, what we have to do is, so initially I told already, this is the structure. Carbonyl is present and 2 electron is there, and then 1 electron is here, 1 positive, and then this is negative. Okay, so now what will be happening? This will go and attack the metal. So now after attacking, so here what has happened? This carbon has given away its electron. So once it is given away its electron, now it will be not minus anymore. It will be like this. Okay, basically the metal has gained that electron. So now the carbon has exactly how many electrons? 1, 2, 3, 4. So it is not having extra electrons, so we are not putting minus charge. Okay, now the next step is to calculate the formal charge. What we have to do is this 2 electrons here 2 electrons, it is coming back here. Okay, so if it is coming back here means it will look like the initial electron. Okay, the same like the initial step. Either these both are same. Now what is the charge of this particular thing? It is 0, right? The plus and minus will be cancelled. So neutral ligands are having 0 formal charge. That is why they are saying, like, we will have more examples, then later on you will understand. Okay, so consider metal and this carbon sulfide. Okay, so this is also a neutral ligand. So how do you know it is a neutral ligand? See, carbon, just write the ligand separately and see carbon, and then 3 bond is there, sulfur is there. Okay, so basically 1, 2, 3, count and see. Okay, whether each of the atom is getting 8 electrons. Okay, here 1, 2, 3, 4, 5, 6, 7, 8. If I add 2 electrons, sulfur will get 8. Then here 1, 2, 3, 4, 5, 6, 7, 8. If I add 2 electrons to carbon is also, I need each electron should have 8 electrons. Basically that is the whole concept. Okay, so now just count and see which is having loss of electron, which is having gain of electron. So sulfur, the outermost electron, it should have 6. Okay, 1, 2, 3, 4, 5, but it is short of 1 electron, so it is plus. See, carbon, it should have 4. 1, 2, 3, 4, but it has 5 electrons, so it is negative. So this is same like carbonyl group only. Okay, so then these 2 electron only will be bind to our metal. That's why we are having the contribution to be 2. So then what will happen? Again the same procedure. This is coming back here. That is how you have to find the formal charge. Then the same structure will be there, and the neutral ligand. So formal charge is what? 0. What about the hapticity? The same. Hapticity is 1. Then next move on to next example. Metal P or 3. So nitrogen. Always remember like this: nitrogen, phosphorus, then oxygen, sulfur. So all these nitrogen will have how many bonds? Usually nitrogen, how many bonds? Just remember the ammonia group. 3 bonds will be there and 1 lone pair will be there. That is the correct procedure. For oxygen, 2 bonds will be there and 2 lone pair will be there. Okay, so whatever group is present in the same group, all of these things will follow the same thing. Okay, now for nitrogen and phosphorus, it is the same. So basically phosphorus, is having 3 OR group in this case. So already the 3 bonds are over. Then another one lone pair will be there. Okay. So this lone pair is only donated to our metal. Okay, that's why the contribution for here is 2. So this is also a neutral ligand. So whenever there is no charge, this ligand is not having any charge. So it is a neutral ligand. So whether it is neutral method or oxidation method, both will contribute 2 only. Okay. In both the method, the ligand contribution is 2 only. What about the charge? We can find the charge. Okay. So metal. Now metal is there. Phosphorus is there. OR group, OR group, OR group. So since this has donated its electron, it is in loss of electron, right? So if you count and see, just count 1, 2, 3, only 4 electrons, but phosphorus should have 5. So now it is in positive charge. Okay. So now what is going to find the formal charge? What I have to do? These 2 electrons will come again here. So what will happen? So now again it is in neutral form. There is no charge. The formal charge is what? 0. Okay, what about hapticity? The metal is bonded to only one phosphorus. So the hapticity is what? 1. Okay, let's move on to next example. M and then N or 2. So they will just give like this. They won't mention any lone pairs or anything. So nitrogen will have how many bonds? 3 bonds, right? So or. So just to take the ligand, okay? Just forget about everything else. Just take the ligand, okay? And then 1, 2 electrons are over. Nitrogen need 5 electrons. 3, 4 and then 5. Okay, now I have drawn 5 electrons. So here this electron is only binding to our metal, okay? So basically the one electron is only binding to our metal and this lone pair is not binding. Okay, so when just remember this, first we have to bind the metals. We have to, first we have to complete all the bonds. Then only we have to go to the lone pair. See, in the last previous thing, we gave this lone pair to the metal. Why? Because already the 3 bonds are over. So phosphorus can have only 3 bonds. That is over. Then only we are giving the lone pair. Here, nitrogen initially had only 2 bonds. So there is a possibility of giving another 1 bond. So that is completed. And now the lone pair will be there. So now what about the neutral? So now we have to, this will have a different neutral and oxidation method ligand contribution. Okay. So in the case of neutral method, the contribution is 1 and in the case of oxidation method, the contribution is 2. So it is very simple. Okay. So nitrogen is there, OR group and then lone pair. So this is in neutral form, right? Basically this is in neutral form, right? So this electron is only donated, right? So if you homolytically cleave this, here only 1 electron, here another 1 electron will be there. Just do that thing, okay? Homolytically cleave it. So whenever it is neutral, homolytically cleave that metal and the ligand bond. Here it is heterolytic cleavage will be happening. Okay, heterolytic cleavage means you know, right? So homolytic cleavage. So how many electrons are there with the nitrogen that is bonding with the metal? Only one, right? But in the case of heterolytic cleavage, what will happen is, heterolytic means like both the electrons are given to 1 electron. So how this nitrogen will look? Nitrogen or and then 2 electrons will be there. Now nitrogen has extra 1 electron. If you count and see 1, 2, 3, 4, 5, 6 electrons, so it is gaining 1 electron. So now there is 2 electrons, right? 2 electrons. Just forget about these 3. Okay. So this electron, this electron, this electron. Just forget about the rest of the thing. Just focus in the bond, how it is forming. Okay. So now only 2 electrons. So here the oxidation method, the contribution will be 2. But in the case of neutral method, the contribution will be 1. Okay. What about the hapticity? Hapticity will be 1, right? So because metal is bound to only 1 nitrogen atom, so it is 1. Then what about the formal charge? So once you are using this oxidation method, the formal charge is easy. So formal charge is what? -1. Already we told how to find the formal charge. We have to take this bond and then we have to take back the electrons. So it has a negative charge. The formal charge is -1. So we will move on to more examples so that it is easy. Okay. Cm and then X. So basically halogen will have how many electrons? 7. 1, 2, 3, 4, 5, 6, 7 outermost shell electrons. So for neutral method, how many electrons? Oxidation method, how many electrons? So neutral method means I have to cleave homolytically, right? So how will the halogen present? 1, 1, 2, 3, 4, 5, 6. So the neutral method, how many contribution? Metal will have 1 electron. So the contribution for neutral method is 1. What about the oxidation method? I have to cleave it like this. Both the bond will come here. So the halogen will look like 1, 2, 3, 4, 5, 6, 7, 8. So minus charge, because it is gaining 1 electron, it is minus charge. So here this 2 electron is donating. So in oxidation method, the ligand contribution is 2. So what about the formal charge now? We can easily say that this has a minus charge, right? So the formal charge is what? -1. Okay, in this case the formal charge is -1. Then hapticity is also what? 1 only. Only one halogen is attached. Okay. Then coming on to the hydrogen. Consider metal hydrogen bond. So homolytically cleave it. Okay. So whenever I am cleaving it homolytically, it will be M and then H. So this homolytic cleavage is for what? Neutral method, right? So hydrogen has how many electrons? 1. So contribution of this particular ligand in neutral method is 1. Okay. Then what about like oxidation method? So 2 electrons, both the bonds will come here. So hydrogen, M will be plus because it has given away its electron, and hydrogen will be minus because it has gained 1 electron. So here 2 electrons are there. So oxidation method, the contribution is 2. And what about the charge? Charge is what? -1. See, only one -1 charge is present. The charge is what? -1. Okay. Then let's move on to alkyl group M, or so instead of or we can take CH3, right? So M CH3, alkyl group. Okay. So carbon has 4 bonds. So first I am homolytically cleaving for neutral method. So how many electrons? M will have 1 electron. Carbon will have 3 hydrogen bond and 1 electron. So what is the contribution in case of neutral method? Ligand contribution is 1. So heterolytically I am cleaving. So what will happen? This 2 electron will go there. So CH3, 2 electrons. So since it is gaining 1 electron, extra electron is there in carbon. If you count and see, 5 electrons are there. So now what is the contribution? 2. For oxidation method, the ligand contribution is 2. Okay, then what about the charge? It is -1 because it has -1 charge, right? So now we will move on to the important ligand contribution, the nitrosyl. See, the nitrosyl, it has the bent structure and linear structure. Okay, so you should not confuse between both. Okay. So nitrogen will have the bend. First we will see the bend structure. This is the metal and this is the nitrogen, and the lone pair will be present. So they may not give the lone pair. Okay. So what is happening here? So this is the bend structure. So basically what is happening here? If you see means, so nitrogen can have 3 bonds. Okay. 3 bonds are already there and the 2 lone pairs are empty, right? So now I am homolytically cleaving it. So metal and ligand homolytical cleavage. For neutral method, how will it be? Metal will have 1 electron and nitrogen is having 1 electron. So basically nitrogen has 1 electron. So neutral method, the contribution is what? 1. Then for oxidation method, what I have to do? CO, this 2 electron will come to nitrogen. So nitrogen will gain 1 electron now. So what will be the contribution here? It will be what? 2 electrons will be contributed. So 2 is the contribution in oxidation method. Then what about the charge? Charge for this bent nitrosyl is -1. As you can see, -1 is present. Okay. Charge for bent nitrosyl is what? -1. Okay. Then moving on to nitrosyl linear. Nitrosyl is present in linear, mostly they will give you, okay, whether it is linear or bent. Okay. So in the case of this linear structure, you have to remember two structures so that you won't confuse. Okay. See, just remember these both structures. Okay, so how to remember this? Both of these structures. See, first remember this structure. Then you can easily come on to here. Okay, so nitrogen is there. Nitrogen is there. So why I'm telling this is linear? So this is sp. So triple bond is there. So sp hybridization. Whenever there is for two double bond, then also it is what sp hybridization. But in this case, this nitrogen is not in sp hybridization. It is where another hybridization is there. That's why it is bent. Okay, sp3 hybridization. Okay, but sp2 hybridization. But in this case, so here it is sp2. So here it is sp hybridization. So this is also correct. This is also correct. Okay. So here what I have to do is oxygen. First check for oxygen. Oxygen will have how many electrons? 1, 2, 3, 4, 5, 6. Okay, everything is correct. Okay, then for nitrogen 1. So nitrogen what? 1, 2, 3. So 3 bond is there. See, what is happening is the lone pair will be there. Two lone pair will be there. Other than this 3 electron, there will be a lone pair. That lone pair only is donated to this metal like a coordinate bond. Okay. So this is the sigma bond. Okay. Downside. Upside. Like I'll write it clearly. Okay. So downside is a sigma bond. Okay. And upside is like a coordination bond. This 2 electron is donated to that bond. So that is a like a coordinate bond. So this particular structure only we are going to use for neutral method. So in this case neutral method, what I have to do means, so basically how many electrons this nitrogen is contributing, just know that. How many electrons? So it is contributing 3 electrons. See, 1, 2, 3. So why 3 means, this is the reason, because I'll write it again. Okay, just put the metal and then the it should be in sp. So I am writing like this. Sp means either it should have two double bonds, or it should have a triple bond. So I am writing this. Okay, now nitrogen. So nitrogen is here. 1, 2, 3. And then 4, 5, this 2 lone pair is giving its electron to here. So basically this nitrogen is now positive charge. And since this metal got the electron, it will have negative charge. Okay. So this is the structure. So basically here you have to count these electrons. How many electrons it has contributed? 3 electrons. That is why nitrogen is 3 in the case of neutral structure. Okay. But in the case of this oxidation structure, we can use this structure. Okay. How you have to draw this structure means, see, minus. Just remember once, then it will be easy. Okay, so what I have to do is, this electron is coming here. Okay, and this electron will go here. So what will happen? Nitrogen. Since this since this oxygen has given away its electron, right? 1, 2, 3, 4, 5. Loss of electron, so plus. And then this nitrogen has now gained electron. So this plus and minus will be cancelled. Again this nitrogen has given away its electron, so it will be again plus. Just count and see, it will be easy for you. Okay, now this metal got another 1 electron, so 2 minus. Okay, so if you count and see 1, 2, 3, 4, only 4 electrons there, that's why it has a positive sign. Okay, so this is like a neutral. See, as you see, 2 minus and 2 plus will balance and everything will be neutral. Okay, so here what is the contribution? As you can see, what is the contribution here? Whether it is 1 electron or 2 electron means, to find the contribution in the case of this oxidation method, what I told, I have to cleave it heterolytically. So what will happen, since it is gaining electron, it will be like this and then positive charge. So now 2 electron is the contribution in the case of what? Oxidation method. Okay. So why there is no negative charge or any charge in this nitrogen? Because see, just count and see, 1, 2, 3, 4, 5. 5 electrons is there. So it is not it has not given any electrons or taken any electron. So charge is balanced. Okay, just count and see. Whenever if you want to give a charge, just count and see whether it has the valence electron. Okay. So now two electrons. So in the case of neutral method, it is 3, and in the case of this method, it is oxidation method, it is 2. Then what about the charge? See, it has +1 charge. As you can see, positive sign is there, right? So this so formal charge is also found using this method only. It has positive charge, so it is +1. But in the case of bent, what was the charge of this one? Nitrile -1 charge. Then next is the metal aryl bond. Okay, so metal and then phenyl group. So how it will be? So C6H5 group is there. Okay. So what about the contribution in neutral and oxidation method? So for neutral method, I'm cleaving homolytically. So metal will have 1, and then this entire benzene ring will have 1. So contribution is what? 1. And in the case of oxidation method, what I have to do? I have to cleave what? It should be cleaved heterolytically. So both the electrons will come here. So the benzene ring is here, and it will have a negative charge here. Okay. So whether like whenever the entire ring is considered, so just note that, so this negative charge is outside the ring and it is not contributing to the aromaticity. Right, aromaticity is followed in this ring, 6 electrons are there. So it is inside the ring, and this negative charge is not going inside, it is not going to go inside the ring. Okay, so it is negative charge. So the formal charge will be -1, and this negative charge has how many electrons? 2 electrons. So the contribution in oxidation method is 2 electrons. So you never have to memorize these things. Okay. What about the hapticity? Hapticity is 1 because it is attached to only one carbon atom. Formal charge is -1. Then let's move on to MCOR. MCOR. So whenever you get like this, just put the structure M, C, and then O, R. Why I have written 2 bonds for the carbon and everything like this? Just remember, carbon has 4 electrons. 1, 2, 3, 4. Okay. So for a neutral method, I have to cleave how? Homolytically. So M and then C double bond O, R. So here only 1 electron is contributed. So for neutral method, the contribution is what? 1. Then what about, you can remember yourself. What about the contribution in the case of oxidation method? So it is 2, right? 2 electrons will be there. So the contribution is what? I have cleaved as heterolytically. So 2 is the contribution in the case of oxidation method. Then what about the charge? Since this carbon is having extra electron, if you count and see, you will know. See, 1, 2, 3, 4, 5 extra electrons, so -1. So the charge, formal charge of this group is -1. Then what about the hapticity? It is bound to only one carbon. The hapticity is 1. Then let's move on to next ligand M, O, and then R. So this is looking like this. Okay. So oxygen can have 2 bonds. The rest will be what? Electrons. 1, 2, 3, 4, 5, 6. Okay. So first I have to what? Cleave homolytically M, and then 1 oxygen. So this is only 1 electron is there. So for neutral method, the electron contribution is, ligand contribution is 1. Then what about, of course, it is cleaving heterolytically. Then the electron contribution will be 1, 2, 3, 4. So this 2 electrons will come here. So 2 electrons is extra. So -1. So the formal charge is -1. And then what about the contribution? It is 2 electrons in the case of what? Oxidation method. So next we will see metal, and then carbon triple bond N, and then R. So this particular compound, so what will be the contribution in the case of neutral and this oxidation method means? Just write the ligand separately. So here there is a positive charge because 1, 2, 3, 4, only 4 electrons are there in nitrogen, and here carbon 1, 2, 3, 4, 5. So this has gained that electron, carbon has gained. So basically these 2 electrons will be contributed to the metal. Okay. So basically this is a neutral ligand because this positive and negative will be cancelled out and it will be 0. Okay. So the charge, the formal charge also will be 0. The neutral method is also it is 2 only, and the oxidation method also it is 2 only. Okay. So whenever you see these type of lone pairs, like whenever there is a lone pair donating from the from here to here, they always will be neutral ligand only. Okay. So next, move on to metal and hydrogen hydrogen bond. It is like this. Okay. So here they are basically representing that these two electrons are given to the metal. Okay. So these are neutral ligands. So whether it is neutral method or oxidation method, what will be the contribution? It will be 2 only. Okay. The charge will be what? 0. Okay. Then consider for double bond. Double bond is connected to the metal. So what will happen? Here 2 electrons. So each bond is having 2 electrons. So that 2 electrons will be bounded. Okay. So whether it is neutral or oxidation, it will be 2 electrons contribution only. Okay. Then for triple bond, consider for triple bond, it is bounding to the metal, only one metal. That also will donate how many electrons only? 2 electrons. Whether neutral or oxidation, it is what? 2 electrons. Then what about carbene? Okay. So metal is there, 2 bond is there, and then carbene structure. Okay. So now here we can actually calculate. So for neutral method, what I told to cleave homolytically. So metal will get 2 electron and the carbon will get 2 electrons and 1 R. So basically these 2 electrons are contributed. So in neutral method, the contribution is what? 2. Then what about oxidation method? I have to cleave it heterolytically, right? So this 2 electron will also go here. This 2 electrons also will go here. So basically metal will be 2 plus. It has lost all the 2 electrons. It initially had 2 electrons that was lost. Okay. So now this carbon has now gained how many electrons? See, 1, 2, 3, 4. 4 like 2 bonds are there. 2 bonds will have 4 electrons. All the 4 electrons, 1, 2, 3, 4 are in carbon now. Okay. So now carbon has 2 electrons extra. So it is 2 minus. So the charge, the formal charge here is what? Minus 2. Then what about the oxidation method electron contribution? 1, 2, 3, 4. 4 electrons it is contributing. In the case of neutral, it was only 2 electron contribution. Then for carbene, so metal, triple bond, C, R. So homolytically cleaving for neutral method. So 1, 2 and 3. Here 1, 2 and 3. So metal will have 3 and then carbon will also have 3 and then 1 R. So carbon has extra electron or anything is present? No, nothing is there. So these 3 electrons are directly donated. So in this case of neutral method, the contribution is 3. Then for oxidation method, I am going to cleave heterolytically. All the electrons will come here. Okay, totally 3 bonds are having 6 electrons. Now all the 6 electrons are coming to our carbon. So how many electrons are extra in this case? Carbon should have only how many electrons? 4. 1, 2, 3, 4. All the 3 electrons, all these 3 electrons are extra only. Okay. So basically, this is a carbene group. Okay, carbene group. So since it has gained how many electron? 1, 2, 3, 4, 5, 6. Okay. So the formal charge is how many? It will be 3 minus. Why I have written 3 minus? Because 3 electrons are extra other than 4. Okay, formal charge is 3. Then what about the contribution? All these things are bonded to the metal, right? So all the 6 electrons are for oxidation method calculation we have to use. For neutral method it was just 3 and then for oxidation method it is 6. Okay. Then we will move on to the next compound. Metal and then CH2 allyl group is present. Okay, CH double bond CH2. So this is an allyl group. So homolytically I am cleaving for neutral method metal and then CH2. The rest will be present here. So basically 1 electron contribution in the case of neutral method. So for oxidation method it will be basically 2 electron contribution. How? Metal is there, CH2 and the rest is present here. So 2 electrons will come here. So CH2 and then 2 electrons. So now it has 1 electron extra. So the charge is minus 1, right? See 1 Hydrogen has 2 electrons, 2 bonds. So 2 electrons, totally 5 electrons is present, extra 1 electron. So formal charge is -1. Then what about the contribution? It will contribute this 2 electrons. So it is 2 electrons in case of oxidation method. Okay. So here sometimes they will give like hapticity is equal to 1. So whenever this hapticity is given for neutral method, you don't even have to try to calculate or anything. Just put that hapticity. That will be the value for neutral method. Okay. So if the hapticity is 3 considered for some case, then for neutral method the electron contribution will be 3, but not in oxidation method. So that's why neutral method is easy. So when the hapticity is considered 7, the neutral method the electron contribution will be what? 7. Okay. So we'll see more examples on that. See N3 allyl. Initially we saw this one is N hepticity 1 allyl. Only one atom was directly connected to metal. But in this case, if you see, they will give like this. Okay. So basically what this means is metal is there. It is bound to CH2 and then CH is there. Double bond CH2 is there. This 2 electrons is also bound to the metal. Here 2 electrons and here 1 electron is bound to the metal. So all these 3 carbon atoms are contributing. So hepticity is 3. So whenever the hepticity is 3, directly we can write what? Neutral method contribution is 3 without even calculating. But still if you want to calculate, you can identify the idea, right? Basically you have to what homolytically cleave it. So metal and one bond will be there, CH2 and one bond will be there. And then this is neutral. So neutral means it is contributing 2 electrons. It will be not changing. So here it is contributing 1 electron. So totally 3. But it is not necessary to calculate in the case of neutral method. So what about oxidation method? It will be 4 actually. So this electron, this 5 complex will give 2 electrons. Another 2 complex will be because CH2, it will be coming here, right? CH2 double bond. So here 2 electrons are contributed. So 2 electrons from here and 2 electrons from this particular bond. So totally 4 electrons. So oxidation method it is 4 electrons and neutral method it is 3 electrons. I hope you understood. Then let's move on to next one. So cyclopentadiene, it is bound to metal. So they have given the hepticity. Hepticity is 1. So because this metal is bound to only one carbon here, right? So hepticity is 1. Hepticity is 1 means the neutral method in the case of ring structures. Okay, basically generally in the case of ring structures just use this. Okay, hepticity is 1, so neutral method is 1. If you want to understand this concept, just homolytically cleave it. Metal will have 1 electron and this particular ring will have 1 electron. So the contribution is 1. Then if you heterolytically, if you cleave it means what will happen? So 1, 2. So two electrons will be gained by this electron. So here 2 electrons will be formed. So 2 electrons is the oxidation state electron contribution. What about the charge? Formal charge will be -1 because -1 is present. Then consider hepticity is 3 for this cyclopentadiene. Okay. So how they will give is they will just give like this arrow and they will bind it with metal. So basically that means is these 3 carbons are involving in the reaction. So if it is confusing, just draw it. Okay. And then put bonds. So this one metal, this one is attached to the metal and this particular 2 carbons are attached to the metal. Okay. So this this two metals will give 2 electrons, right? And then here if you homolytically cleave it 1 electron. So basically 3. So that's why neutral it is 3. Hepticity is 3 means neutral is 3. Then what about oxidation state metal? Oxidation state method also the same only. But if you see this will contribute 2 electron whether it is oxidation or neutral. But here 2 bonds are there. So here 2 electrons will be contributed in oxidation method like if you heterolytically cleave it. So totally 4 electrons. For what? This particular next we will move on to hapticity is equal to 5. Hapticity is 5 is given, means they will give just a round like this and they will give like this. Basically this means is all the 5 carbons are involved in the reaction. So if you want to write it clearly means, so metal is there and this is also contributed and this is also contributing. It will look like this. Okay. So for neutral method, since this is 5, for neutral method the contribution will be 5. What about the oxidation state? Here 2 electron, this 2 bonds 2 electron, and this here particular bond heterolytically cleavage, it will give 2 electrons. So for oxidation method it is totally 6 electrons. Okay. Then what about the charge? The formal charge will be -1. Okay. Because see, so whenever calculating this formal charge, just check if this, whenever the entire ring is contributing, just remember this entire ring is contributing, then you have to check the aromaticity. So aromaticity is checked only when all carbons are involved. Okay, all carbons are checked only if all carbons are involved. Okay, so 1, 2, 3, 4, 5, 6. So 6 electrons means it is aromatic. I hope you know how to what are all the values for aromaticity. 4n plus 2 rule. So if n is equal to 1, what will be the value? 6. If n is equal to 0, what will be the value? 2. So 2, 6, all these numbers will consider as aromaticity. Okay. So whenever you are having this particular thing, you have to check whether it is aromatic or not. So the charge here is -1. Okay. Next, let's move on to like butadiene. So consider they have given like this metal. So heptacity is what? 4 they have given. So neutral method, the electron contribution will be what? 4. Because this will look like this, right? So this one will give 2 electrons and this one will give 2 electrons. Then what about the oxidation method? So oxidation method, so here oxidation method is the confusing part here. It will have either, it should follow this aromatic rule. Since here 4 electrons are there, 4 electrons is anti-aromatic. Why? 4 and rule, whichever is following 4 and rule means it is anti-aromatic. So 4 electrons if it is there means it is anti-aromatic. So for aromatic, what are all the numbers? 6, 2, and then 4 and plus 2. If we add n is equal to 2, what will be the value? 4 2 are 8, 9, 10. So 10. All these things will be aromatic values. Anti-aromatic means 8, 4 3 are 12. All these numbers will be for anti-aromatic. 4n. This is 4n anti-aromatic. 4n plus 2 for aromatic. So now I have to attain aromaticity because now it is in anti-aromatic, right? 4 electrons. So I can either gain 2 electrons so that I can get to 6 or I can release 2 electrons so that it will be 2. So whenever it is giving away 2 electrons, it will be positive, okay? Or it can gain 2 electrons and it will be negative. See, here it is totally 6 electrons. Here it is totally 2 electrons. See, it has lost 2 electrons. Lost 2 electrons. Here it has gained 2 electrons. So this is the 2 positive ways, okay, to attain this. Now, between these 2 structures, which one is more stable and why? So see, whenever a metal is bound to a carbon, the carbon is more electronegative than the metal. So the carbon will mostly gain the electron. So based on electronegativity, the metal is always a donor group. Okay, so carbon will always gain from the metal. So it is better to gain electron than to lose electrons. So this will be the contribution, 6 electron contribution in the case of what? Oxidation method. In the case of neutral method, it is 4. Okay. Then let's move on to benzene ring. If they have given like this means all the 6 carbon atoms are contributing. So the neutral metal contribution will be 6. And for the oxidation method is also 6. Why? Because it is already aromatic. So earlier case it was anti-aromatic. So we changed it to aromatic. Here it is already aromatic. Already it is 6 electrons. So the oxidation state is also it is 6 electrons. Okay. Then hepta compound. So 6 carbon is there. Consider they are giving like this. So basically it means these 3 carbons are involved. The heptacity is what 3. So neutral method the contribution will be 3, right? What about the oxidation method contribution? So here you have to check the you have to draw the structure and then like put like this. Okay, here metal is there and then this is also contributing. So here 2 electrons will be contributed, from here 1 electron. That is why it is 3. But in the case of oxidation method, what will happen? 2 electrons will be contributed, right? Because it will be cleaving heterolytically. I hope you understood what I am trying to tell. So metal bond is there. So this will be cleaved heterolytically. So 2 electron will be there. So oxidation method totally 4 electrons will be contributed in the case of oxidation method. Okay. So here only three carbon atom is considered. So you don't have to check any aromaticity or anything. Okay. So aromaticity is checked only if all the carbon atoms, if in this case all the 7 carbon atoms are involved, then check the aromaticity, okay, for oxidation method, okay. Then for N is equal to 4, I mean heptacity is equal to 4 means neutral method contribution will be 4, right? So consider these 4 electrons. So oxidation method also it will be 4 only. So I asked you not to check the aromaticity in these cases. Okay. So in the case of 6, consider 6, 1, 2, 3, 4, 5, 6. So all these carbons are involved. Then neutral method is also it is 6. Oxidation method is also 6 only. Now consider heptacity is 7. They have given whenever round is given the entire carbon heptacity is 7. For neutral method you can directly write 7, but for oxidation method since the entire carbons are involved, now you have to check what aromaticity, whether it is falling aromaticity or not. So 2 electron, 2 electron, 2 electron, and then this is bound to here. All these things will be bound. Okay, every metal, every electrons is bound. Here there is two possibilities. Okay, there is two possibilities. Either this can gain the electron or this metal can lose the electrons and it will be positive charge. So which is stable? Here 6 electrons are there, right? Whenever I mean here 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. So 8 electrons are there. Here only 6 electrons are there. So which is more stable? Aromatic. So that is why we are putting positive charge here. So the charge for this, the formal charge for this particular ligand is what? Plus 1. Okay. It is not minus 1. So metal will gain the electron. Most of the cases the metal will lose electron, but certain cases like this, because to attain aromaticity it has to lose the electron. So it will lose the electron. So here now the contribution here is how much? 1, 2, 3, 4, 5, 6. So 6 electrons. For oxidation method, the contribution is how much? 6 electrons. For neutral method, the contribution was 7 electrons. Okay. Then coming on to octa compound. So octatetraene, cyclooctatetraene. So this is N is equal to 8. Consider all these things are involved. Then for neutral method, the electronic contribution is what? 8. But in the case of oxidation method, we don't need it actually because it is anti-aromatic. We have to attain aromaticity. So either both is electrons are released or it can gain. Okay. So from 8, I either need 6 or I can go back to what minus 2 means 6 plus 2 means 10. So either 6 or 10, both are aromatic. Okay, I don't need 8. Okay, so here if you see 1, 2, 3, 1, 2, 3, 4, 5, 6, 6 electron. Here if you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 electrons. So both are possible because both are aromatic, both are aromatic, but we have to choose between these structures. Okay, so since it is confusing, I told a metal is bound to a carbon, means always carbon will gain the electron because both are aromatic. Okay, so it is going to gain the electron. So this structure is followed. So our oxidation state, the electronic contribution will be 10 electrons, not 6 electrons. Okay, and then we will move on to tricyclo tricarbon group, cyclopropane. Okay, so here if they have given all the metal, the hapticity is 3, so the neutral metal contribution will be 3. But in the case of oxidation method, we have to check aromaticity. So see, 1 electron, and either minus is possible or plus is possible. So this is having 4 electrons, this is having 2 electrons. So this is what anti-aromatic. Here this is aromatic. So of course which we have to follow this one. Okay, so the contribution is 2 electrons in the case of oxidation method, and not neutral method it is 3 electrons. Okay, and then C60, carbon 60 structure. So here this particular carbon 60 structure, this is a nanoparticle. It will have hexagon and pentagons, everything will be present. Okay, mostly the carbon is in sp2 hybridized oxidation state. So here the contribution, whether it is neutral or it is oxidation, the contribution will be 2 electrons. Okay, in the case of fullerene. Okay, and then we will move on to bridged compound. So bridged is very important. So whenever using bridged ligand, whenever bridged is present, it's better to follow neutral method. It is easy. But I will also talk about the oxidation method. But still, just don't confuse with oxidation method in bridged, because it is very confusing. Okay. So consider a metal is present and then carbonyl group is present. So two metal is present. Okay. So I have to cleave what? Homolytically. For neutral method I am doing. Okay. Metal will have 1 electron, carbon is 1 electron, and then here 1 electron metal. So it will be cleaved like this. So basically carbon had how many electron contributed? 2 electrons. That is for neutral method. Just assume for now for oxidation method. Oxidation method, both the electron will come here, both the electron will come here. Is that the thing? No, that is not going to happen here, because so here it will not be acting like this. Instead, it is also in the case of oxidation method also it will contribute to electrons only. That's why I told this is confusing. Okay, so whenever there is a neutral ligand, just remember this, whether it is a neutral method or oxidation method, it is going to give the same number of ligands. So CO is already, we told CO is what? Neutral ligand. Okay. Then consider our halogen. Halogen is here. So basically halogen can form one bond and then 3 lone pair will be there. But if you see here, halogen has bond 2 bonds. Okay. So what 2 lone pair is there and then 2 bonds are there. So one lone pair, see, just remember this. So this one lone pair is given by the halogen. And in this case, this one electron is given by the halogen, and in this case, one lone pair is given by the halogen to the metal. So basically, 3 electrons are contributed, right? So halogen will look like this: 1, 2, 3, 4, 5, 6, and 7. So basically, this 2 electron and this 1 electron is contributed to the metal. That's why it is 3 electron in the case of what? Neutral method. So this is for neutral method. What about oxidation method? Oxidation method, what we will do? We will heterolytically cleave, right? So heterolytically I am cleaving. So what will happen? It will gain 4 electrons. 1, 2, 3, 4. So how many electrons is extra here? 1 electron. So it is minus 1. So the formal charge here is minus 1. And then the contribution is how much? 1, 2, 3, 4. This is also given. This is also given. So 4 electrons is the contribution in the case of oxidation method. For neutral method, it is 3 electrons. Okay. Coming to metal, hydrogen, and then metal bond. So basically hydrogen has only one electron. It can only provide only one electron. So in the case of neutral, it is only one. Hydrogen doesn't even have extra electrons. So in this case, only the metal can donate the electron. Okay, so in the case of neutral, it is one electron. But in the case of oxidation method, what we have to do is, this one electron is here and this is gaining heterolytically. I am cleaving this one particular bond. So what will happen? So H 2 minus. So 2 electrons. So 2 electron in the case of oxidation method. I am not going to use this bond. Why? Because only one electron was from hydrogen. Actually this bond itself is from metal. There we cannot heterolytically cleave. Okay. So if it is confusing means just follow the neutral method. Okay. Then we will move on to carbon triple bond. So carbon, whenever carbon triple bond is there, two metals. So here two electrons will be contributed. For this metal, two electrons will be contributed. So whether it is neutral or oxidation, the contribution is what? 4 electrons. Okay. Then N or2. Okay, N or2. So basically nitrogen can have 3 bonds and one lone pair. So now this is what is going to bond. This now electron is going to bond to a metal, and this lone pair will be given to another metal. So how many electrons are basically involved means 2 plus 1, so 3. So neutral, the electron contribution will be 3. If you want to check for oxidation method, so this 2 will be same because this 2 will be given by the nitrogen. But in this case, this will be heterolytically cleaved. So it will look like this. Heterolytically cleaved and look like this. Minus 1 charge. So this electron, so totally 4 electrons in the case of oxidation method contribution. I hope you understood how this electron contribution and everything is working. In our next video, we will learn about how to calculate the 18 electron rule for entire complex using these ligand contributions. Thank you for watching this video. Like, share and subscribe my video.